morning to one and all. So myself, Sreekanth, I am working as an assistant professor in the Department of Data Science. So today I want to discuss about one of the course for third years, that is cloud and big data. So I want to discuss here big data concepts, like what exactly big data, okay, how to process that big data, what are the challenges we are facing in big data. So we need to discuss some of the concepts related to big data. So before going to the big data, so we need to learn some of the basics related to what exactly data, and then what are different formats or different types of data. Then after that we need to discuss about the what exactly big data, what are the 3 V's or 5 V's of big data. Technical definition we'll discuss later. First we'll go through what exactly data. So data is nothing but facts and figures, nothing but in the form of like numbers, text, images, or any other format. That is basically we are calling as a data. So here this particular data, like suppose for example 2, 3, 4 something you are writing. So this is also a data. This is also a data, but this data is the basic building block for information, okay, and that is very important. So here in the context of computing and technology, data can be processed and manipulated to derive meaningful insights. For what purpose we are using this particular data? Finally, our objective is to find out some useful insights from this particular data. So that is the main motive or objective of this particular data. This particular data is a basic building block for information and knowledge. Then there are different types of data is available, like a structured type is one category, and the second one is unstructured, then third one is semi-structured. What is the structured data? Structured data is nothing but data is organized in one format, organized in one specific format, like something like in the form of rows and columns. You are arranging the data, so that is comes under structured. Means finally you are organizing the data in a one specific format, that is comes under structured data. So the examples for the structured data, just basically we are observing the Excel sheets, spreadsheets, or databases, whatever you are using, okay, in our day-to-day life. Basically those are comes under structured data. Means we are arranging data in the form of something called rows and columns kind of thing we are using. Unstructured data is nothing but here there is no predefined structure, there is no predefined data model or a schema, okay, so it is not organized manner. Structured data is organized manner, the data is organized in one specific format, but in unstructured there is no predefined schema, so that is unstructured. So the examples for unstructured data, text documents, like some word processing file, if you are taking some text you are writing, so that is comes under unstructured. Means you are organizing in a something like a rows and columns kind of thing. So if you are not organizing in a rows and columns kind of thing, or a Excel sheet format, or spreadsheets, or any kind of Google sheet format you are not following, so means simply images, all these comes under unstructured data. Maybe social media posts like LinkedIn or maybe Twitter, so any social media posts, whatever it may be, so that data is comes under unstructured data. So then next, the third type is semi-structured data. So this is falls between structured data as well as unstructured data. Means this is not completely fully organized, and at the same time this is not completely not organized data. Maybe so in between structured and unstructured, means you have some organization properties, but it doesn't fit nearly to the traditional tabular structure, like our tables contains rows and columns. So something like you can manage data between structured and unstructured. If it is not fit for unstructured, at the same time it is not fit to structured, in between that is comes under semi-structured. Basically any semi-structured, like something, if you know JSON formatted data, JavaScript object notation, something like a key value pairs, something like a key value pair you are representing. So or else XML format data, like a tags kind of thing you have. So something like this if you are representing, that is comes under semi-structured data. Then some of the key characteristics of this semi-structured data: flexibility. One is flexibility. Semi-structured data is more flexible than your structured data. Why? Because here schema is not fixed. Schema is not fixed. Dynamically, according to your requirement, you can enter data. Okay, there is no rigid strictly schema. Okay, we are allowing different variations while storing a data. So that flexibility is available in semi-structured data type. And tagging or markup, whatever it may be, like JSON formatted or XML formatted data, so that is comes under semi-structured. So nested structure, nothing but hierarchical data. Suppose I have something like, for example, student. Okay, as a one tag I am representing. Inside this, you can take a different tags, sub tags. You can take roll number, name, something like marks. Under the marks, different subject marks. You can represent a different data in a hierarchical manner. For that purpose, also you can use this semi-structured data, something like XML formatted or JSON format. You can use. And variable schema means there is no fixed schema. In structured data, okay, you have a fixed schema. Once you are fixing, in the same way you need to store the data in a structured. So, but in semi-structured variable schema, so it allows variations in the schema. Like maybe sometimes some records may have some attributes. Maybe another record may have 10 attributes. Maybe a third record, maybe you have 15 attributes. Like different variations in the schema, not a fixed schema. That is called a variable schema. And JSON formatted data and XML formatted data and NoSQL data, something like so whenever it is not fit into your traditional databases like maybe MySQL or PostgreSQL or a SQL Server, when you are storing the structured data in those RDBMS, so if that is not fit, for example, if some data is not fit in traditional databases, then obviously we are using NoSQL. Not only SQL, okay, as it is in a structured, you can store at the same time. Whenever you have something data with something like not fit to your traditional databases, you can use this NoSQL databases. That is comes under semi-structured data. And next, that is about the data. Then next, coming to information. What is this information? So previously I said that okay, one of the basic building data is a basic building block for information and knowledge. So information is nothing but processed and organized. Data is not a processed one, it's a raw data. Like something, for example, if I am using the 18.4, suppose 2004, something like this, if I am using. So okay, this is called as a information. Suppose, for example, if you are taking 18.4, 2004, if you are taking like this, so there is no context and there is no relevance in this particular data. This is only simply a raw facts and figures. When you are adding some context to this particular data, something like this, some slash or hyphen, then you can identify, okay, you are representing something, a date, maybe anything, maybe a joining date or maybe a date of birth or maybe a something, maybe a order date, something. So whatever it may be, but you are adding some context and relevance to this particular information. So that's why information is processed and organized data that has a context and relevance and meaning. There is a specific meaning. So if I am writing something like 2004, then what you can think about this? Only these are facts and figures, just numbers, that's it. You cannot identify what exactly it represents this particular data. When you are adding context and meaning, then you can identify this is information. While data consists of raw facts and figures, information provides a framework for making decisions and taking action. From this particular something, suppose for example, I am taking a sales data, for example. In a sales data, okay, something I have some column like order date. Order date is a one column. So from this, okay, you can identify order date on which, suppose for example, I want to find out total sales done in the previous month. According to the date, you can find out total sales done in the particular store. You can identify, you can find out some decision, you can find out some insights from that, and based on those insights, okay, you can take some decisions, proper decisions to improve your business. That is the main purpose of information. The main objective or motive of any information nowadays is you need to find out some useful insights from that data, and finally we need to take up some proper decision, and finally you can improve the business. That is the main idea behind the processing of any information. And some of the key characteristics of this particular information is context. Information is meaningful with a specific context, and the relevance. Information is pertinent and applicable to the particular purpose or question. So when you are taking any information, so there should be a relevance, means it should be applicable to a particular purpose. Means here if I am writing something, means this is related to something, order date, something maybe date of joining, or maybe something you are mentioning. So because of that reason, okay, information has some relevance. And organization means information is structured and organized in a way that makes it understandable and usable. Okay, finally we need to interpret this information into raw data, into insights, and often it requires some analysis to processing to extract valuable meaning. Means you need to identify some valuable insights from this information. So finally we are communicating this information to others, so that you can transfer this particular knowledge to others in the team members, or maybe some other one. They can take some decisions. Suppose higher level management are there, they are asking some analysis over the some sales related data. So finally, as a analyst, you are providing some useful insights, and based on those insights, higher level management, they will take some decisions to improve their business. So what item is maximum sold, and what is sales in the previous year or maybe previous month. So that you can predict upcoming year, or maybe next year or next 2 years, how their business they can predict. So based on that, they can take some decisions. So that is the main purpose of information. And coming to our actual subject, that is big data. Today's session is big data. What is this big data? Already you know data, information, and different types of data like structured, semi-structured, and unstructured. You know, what is this big data? Why it is important? What is the importance of this big data nowadays? Data is growing day by day, like anything. Like in 10 years back, if you observe, 100 GB of data is nothing but that is the largest memory. If you observe, okay, 100 GB is nothing but that is the largest one. That is the largest one. Okay, nowadays, if you observe, because of digitalization, everything is digitalized. Because of that, every transaction is maintained some information. So because of that reason, now 100 GB is very, very less. Now we are talking about terabytes and petabytes and exabytes and zettabytes of data we are talking. Okay, so this is very, very important. Means as day by day, data is growing like anything. Okay, maybe after 1 month, maybe terabytes of data becomes petabytes of data becomes a exabyte. So to process that, okay, we require some advanced tools also. But before that, how you are calling this data is big data and this is small. Something like how you are identifying this is a big data. Means big data, suppose you want to define, we have basically 3 V's. We have 3 V's, nothing but one is volume, velocity, and variety. Another one is variety. So we'll discuss one by one what are these terms. Okay, whenever you have these 3 V's, basically 3 V's, you have more than that also. Okay, veracity also you have. Okay, so we'll discuss first these 3 terminology. Well, volume, velocity, variety. Volume is nothing but big data involves massive or a large amounts of data. We can call it as a large amount of data or a large volumes of data. Large volumes of data means according to the application requirement. Okay, we are talking like 1 TB of data. Sometimes we are calling as a large volumes of data. Okay, means basically here they are calling ranging from terabytes to petabytes. Minimum terabytes of data to suppose 1 terabyte to 1 petabyte. 1 petabytes of data. This is basically we are calling as a large volumes of data. Okay, then only we can call that data is big data. That data is a big data. So you need to define, okay, 1 PB of data you are processing, or else 1 TB of data you are processing, or 1 exabyte of data you are processing. Depends upon that, we can call it as a big data. That is one of the parameter we are taking. So you want to define, okay, a specific data as a big data. This is one of the parameter, volume. The next one is velocity. Velocity is nothing but at what speed you are getting a data. What speed means here, so whether you are getting a real-time data or a near real-time. Real-time data means less than 5 seconds. Less than 5 seconds, that is comes under real-time. Okay, suppose every second if you are getting, that is comes under real-time. Near real-time nothing but 5 seconds or 6 seconds, something we are calling as okay, that is called as a near real-time. So when you are processing the real time or near real time, okay, so near real time, suppose something like every day you need to process some social media data or a sensors data you want to process, or else a financial transaction every second you need to process, that is comes under streaming data. Every second, every 2 minutes, every 1 minute or less than that. Okay, whenever you are calling less than the 5 seconds or 1 second, that is comes under velocity. Big data is generated with high speed. Okay, not a bunch of data or a batch of data. We are not calling as a velocity. A batch of data is nothing but you are storing in somewhere some 1 GB, 1 TB or 1 PB of data, and you are processing something that is called as a batch data. Stream data, that is then only you are using a velocity term. Streaming is means continuously the data is flowing. That is called as streaming. So at what speed the data is generating, like less than 1 second or a real time or a near real time, then only that is called as a big data. And the third terminology, that is big data variety. Okay, big data comes in a various format. The data type, already we discussed, structured data, unstructured data, semi-structured data. Here big data comes under structured data, unstructured data. Structured data means like databases, spreadsheets and Excel formatted data, that is structured data. Or maybe unstructured data such as text, image, videos, all these comes under unstructured data. Semi-structured data is nothing but XML formatted data or JSON formatted data, that is comes under unstructured data. So if you are processing any type of data which is like okay, structured, unstructured, okay, different formats of data, that is comes under big data variety. Then not only these three V's of okay, we can call it as a big data, like volume, basically three: volume, variety, okay, velocity, these three. Not only these three, in addition to these three V's, we have two more V's. Those are called as a veracity and value we are adding. Veracity is nothing but quality and accuracy of the data. How much accuracy, how much reliable your data, okay, whatever the data you have, okay, first whether that data is reliable and the quality data or not. Okay, suppose if that data is not that much reliable or accurate, then if you are finding some insights and based on those insights, if you are taking some decision, you will not get efficient results. So that is the biggest problem. So that's why we need to consider, okay, whenever you are calling a specific data as a big data, you need to include this one also, veracity. Veracity means quality and accuracy of the data. Then the next one, last one is, that is value. Value is nothing but extracting valuable insights from that data. Suppose you are not identifying the proper insights from that data, then again that is not useful. So for that reason, so we need to identify the valuable insights from that data. Then if you are giving the same insights to the higher level management, they can take some decisions to improve their business. So that's why value is also important. Means overall 5 is we discussed, okay, volume, velocity, variety, veracity, value. These 5 is we are calling as a big data. So to find out some insights from the big data, maybe large volumes of data, maybe you are getting a data at a high speed, or else a different formats of data, or else a different quality of data. Okay, you want to find out some insights from this data. You require some advanced analytics and machine learning algorithms and some technologies, advanced technologies, and some distributed computing frameworks like Hadoop and Apache Spark you need to use. Suppose you want to process all these things. We'll discuss later stage all these distributed computing framework. For storage, we have HDFS related to Hadoop distributed file system. At the same time, to process this big data, we have some advanced tools, something like MapReduce and Spark also we can use. Like, so finally, our goal is to extract meaningful patterns and trends and knowledge that can inform business decisions to optimize the process and gain the competitive advantage. That is the major motive. For any business, if you are doing, okay, you need to identify the insights. So some useful insights. Based on those useful insights, you can take some decisions. Better decisions you can take to improve your business. So that is the overall objective of any big data or anything. So some of the challenges in big data processing and analysis. So that is okay. So one of the challenging is data volume. As data is growing day by day. Just now we discussed like PB to XB or a TB to PB. When you are talking, means whenever you are dealing with large volumes of data, maybe in terms of volume, means size of the data. So it's very difficult to manage storage for that large volumes of data. That is one of the major challenge. Okay, you require more space, storage space is required to store this large volumes of data, maybe TB or PB or XB, whatever it may be. So that is very, very important in traditional, okay, that is one of the major drawback in terms of capacity and scalability. So in traditional approach, you cannot scale up or scale down automatically. So that is one of the major challenging nowadays to handle this big data. Okay, scalability is a major issue here. Ensuring that system can scale to accommodate growing data without the degradation in performance is critical. One of the major challenging is here scalability. In what way we are saying this is a major challenging here? As the data is growing day by day, suppose today you are dealing with 1 TB of data, suddenly maybe tomorrow you are getting a 1 PB of data, 1 petabytes of data. So it's not so easy to handle that 1 PB of data. Why? Because as of now, your system can handle 1 TB or 1.5, not more than that. Then how you can handle that 1 PB of data at a stretch? So without degrading the performance of your system or application, you cannot scale up or scale down. You cannot scale up the resources. So that is one of the major challenging nowadays. And the second challenge is that is data variety. Data variety is nothing but different types of data. We are getting data from different sources, multiple sources. Maybe you are getting data from the maybe databases, different databases, or maybe from the sensors, maybe IoT devices, or maybe some other storage services. Maybe data is available in some other cloud also. So we are getting data from different sources. And that data may be a different formats and different structures. Obviously, we need to handle that complete data with a different formats and different structures. Again, it is the biggest challenge. So we need to handle that heterogeneous data. Heterogeneous data means structured type, maybe semi-structured type, or unstructured data type. Okay, maybe whatever it may be the data. So you need to handle. So for that you require a different processing tools, advanced data analytical tools you require to process that different kinds of data. That is a major challenge. And the third one is data velocity. Means as the data is getting at a high speed, means like a real time or a near real time data. So for that, to process that real time or near real time requires highly efficient and low latency systems. That is very important. So when you are ingesting the data, means streaming data, I'm talking about the streaming data, means real time data, near real time data from multiple sources, suppose maybe IoT devices or social media, okay, without losing any even a single byte of data is challenging nowadays. So we need to catch that data. Suppose IoT sensors data is coming from every second. To catch that particular data and to process that data is one of the biggest challenge again. So the next challenge is data veracity. Data veracity is nothing but accuracy of the data, and the consistency is very, very important. Why? Because to perform some analysis on that particular data, if the data is not a quality data, means if that data is not a consistent and accurate, and obviously you will get you will not get some useful insights from that data. That is data veracity. And for that you need to perform some cleaning, and not so easy to identify where the errors are occurred, and to remove some duplicates, or maybe you have some noisy data is presented in that data. To fill that, okay, we need to use the different functionalities we need to use and technologies we need to use to perform all these things. Means not so easy to clean that noisy data, or maybe the data may be presented some duplicates data. If you have all these things, you cannot identify useful insights from this data. So that is also biggest challenge. Then coming to data management, that is another challenge while processing the big data. Metadata management means suppose you want to keep track of metadata for data governance and discovery purpose we are using. So if you are not maintaining the proper metadata, okay, then it's very difficult to maintain something like data governance and discovery and usability. So data governance is nothing but implementing policies and procedure to ensure data security to the user's data, privacy and compliance with the regulations. This is the biggest challenge. Data governance means providing a security to the user's data. That is very, very important. The next challenge is computational complexity, resource management. Here computational complexity means here you need to allocate some of the resources to process your application according to your task. You require some computational resources. So computational resources efficiently to handle intensive processing tasks without wasting anything. Means some more intensive memory intensive tasks or computational intensive tasks are there. So you need to allocate the resources to those tasks properly. That is also biggest problem. Which task is taking more resources, which task is taking less number of resources, that is also challenging. Means for that you need to use some algorithms for optimization. So if you are not using the proper algorithm, okay, to optimize that, so then obviously you will not get an efficient result. So for that, for large data sets, if you want to use some algorithms to optimize the performance, so that is one of the biggest challenging nowadays. And the last one is security and privacy. Okay, data security, protecting data from unauthorized access. This is very, very important for any data. So if you are not protecting the user's data, so then next time no one will choose your suppose your system or application. Why? Because if you are not protecting a user's data, then no one will use your application or maybe anything, maybe your system. So if you are providing a proper security mechanisms you are using, then everyone will prefer. That is very, very important. Nowadays that is very, very important. Why? Because sometimes the data may be sensitive, some data may be sensitive. For that you require high level security mechanisms. So privacy, ensuring that sensitive data is anonymized and is handled in compliance with the privacy regulations can be complex. So that is very, very important. So all these are the challenges we are facing while processing the big data. Okay, whenever you have a data large volumes or a data with a high speed or a different varieties of data or maybe security concerns or maybe a computational complexity. So all these are the challenges of big data. Okay. Then next coming to Hadoop and traditional systems. What is this? Okay, why we are comparing this Hadoop and traditional systems? Means traditional systems means whatever the processing you are doing uh, as of now, means you are purchasing some resources and you are performing some tasks, and that is simple, means maybe you are taking a very less amount of data you are processing, but your traditional systems or approaches are not suitable to process large volumes of data. So that's why we are using some advanced frameworks. We are using one of the advanced framework to process that data is Hadoop. Hadoop is one of the advanced framework to process your big data. Okay, so Hadoop is a big data framework. Hadoop is a big data framework. You are comparing Hadoop with traditional systems. How these two are different, okay, each other. So in terms of data storage, Hadoop uses a distributed file system. So this is one of the advantage. Hadoop distributed file system we are using to store large volumes of data across multiple nodes. Why? Because Hadoop is nothing but a cluster. Hadoop is nothing but a cluster. Cluster contains multiple nodes. Across all these nodes, you are storing large volumes of data. So distributed nothing but across multiple nodes, you are storing this particular data. That is the advantage. And if any fault tolerance, okay, so it provides a fault tolerance also. If any failures occurs, the data is the same data will be replicated in other nodes. If something is failed, if something is occurred, so you can take the data from other nodes also. That is the advantage of Hadoop distributed file system. And in a traditional systems, okay, we are using a relational database, or maximum you are using file systems for data storage. RDBMS or else file systems you are using. But RDBMS can store only structured data. RDBMS you cannot store unstructured or semi-structured data. So that is one of the drawback. And not to, okay, maybe a certain limit only you can process, you can store in RDBMS, but large volumes of data you cannot store in your RDBMS. And that too, for a transactional processing purpose, majorly we are using these relational database management systems. And file systems like NTFS or ext4 are typically used for file storage purpose only. So that is the biggest drawback of traditional systems. So that's why we are moving to, okay, big data processing framework like Hadoop kind of thing. To store large volumes, okay, we are using a Hadoop distributed file system, one of the tool we are using in Hadoop framework. And the next one is data processing. Okay, how these two are varying, traditional approach and Hadoop. For a data processing, okay, you are storing large volumes of data, that is fine, but that data needs to be processed finally. Why? Because to find out some useful insights from the data, so obviously we need to process that data. So for that, okay, in a Hadoop, we have some advanced tools are there to process that. Something like MapReduce we are using, MapReduce, or Apache Spark you have, okay, by using these tools you can process any kind of data you can process, both the batch data and stream data you can process by using these Hadoop advanced tools, okay. And some query processing tools also there, okay, like Hive, Pig also you can use. So easily you can process and usually you can find out some insights. You can analyze that data with the help of those tools in Hadoop. And while coming to traditional systems, okay, you are using a single node processing, but Hadoop is nothing but multiple nodes in a cluster. At the same time, multiple clusters you are taking, and you are doing a distributed processing. So obviously there is a big difference in terms of efficiency wise. You are using a single node, nothing but maximum you can okay, process a certain limit only. Okay, you have the limitations for data size also. So you can process only that data only. You cannot process after that. So that is one of the biggest drawback, and only you can analyze certain data sets, not a complex data sets. You cannot process by using a traditional system approach. That is one of the drawback in traditional system. Then coming to the next one is scalability issue. Scalability, Hadoop, okay, you are taking a cluster, nothing but automatically according to your resource requirement. Maybe suddenly the data is growing, that data needs to be stored and processed. So you can scale up. Okay, automatically 3 nodes you require, automatically you can scale up, you can add nodes to the cluster, you can add the nodes to the cluster. And in a traditional system, it is a single node. Okay, if something is happened to that particular node, okay, you cannot okay, process. Means standby node you need to take, means another server you need to take, and again from the scratch you need to perform all these tasks in a traditional approach. So that too, that server capacity is limited in a single node. But whereas in Hadoop, multiple nodes are there. If one node is failed, automatically another node will be activated, and the same task, whatever the task you performed on the okay failure node, the same task you can perform on another node. That is the advantage. Scalability. Scalability is available in Hadoop. And the next one is data variety. So data variety comes to here. Hadoop, okay, different types of data you can process, but whereas in traditional system approach you can process structured data only you can process. That is the major difference between data variety. And the cost wise, Hadoop, when you are processing large volumes of data, okay, Hadoop is a cost effective compared to your traditional systems. Why? Because so here we are processing large volumes of data. We are using here commodity hardware. Means this is a open source software or hardware is available. Okay, finally you can reduce the infrastructure cost compared to your traditional system. So highly expensive hardware software licenses procure. Okay, you require some licenses softwares whenever you want to process. In traditional approach, large volumes you want to process. So suppose for example high performance databases and enterprise storage solutions, obviously you required some licensed softwares. So obviously licensed software is nothing but costly, obviously. Okay, that is another important point. Okay, cost wise Hadoop is the best option. So you can process with a less cost, means cost effective. Hadoop is a cost effective. So that is about the basics of this Hadoop and big data basics. Okay, then coming to Hadoop ecosystem. Okay, Hadoop ecosystem means what it contains, what are the major components of Hadoop. We'll discuss that. Basically here 4 different phases are divided. 4 different, 1, 2, 3, 4. There are 4 different phases are there. If you observe this particular Hadoop ecosystem architecture. So data storage phase, data processing phase, data access phase, data management phase. Data storage phase, something like which is used to store the data. Processing is nothing but for analyzing. Okay, for processing that data and transforming one type to another type, we are using a data processing phase. And the data accessing, whenever you want to analyze that particular data, so you are using data accessing with the help of some advanced tools. And data management is nothing but whenever you want to perform job scheduling kind of thing or managing the clusters, something like we are using data management tools. So in data storage phase, we are using something called as HDFS and HBase. Hadoop distributed file system and HBase you are using. HBase is a NoSQL database, and data processing side something we are using MapReduce and Yarn you are using. MapReducing and Yarn. And data accessing side Hive, Pig, Mahout, Avro and Scoop we are using. And the data management side Uji, Chukwa, Plum and Zookeeper we are using. So these are the some of the tools which you are using in your Hadoop ecosystem. So according to your requirement, you are using some of these tools you are using in Hadoop ecosystem. So data storage, data processing and data access, data management related phases are there. So that is about something like Hadoop. Okay, so Then the next one is we need to talk about the data storage. Data storage is nothing but here how we are storing a large volumes of data in a Hadoop. For that we have a one specific tool is there. So that tool name is HDFS, Hadoop Distributed File System. Whatever it may be the size of the data, you can store that data simply in your HDFS. So HDFS architecture contains basically primary node name that is called as a name node, and the worker nodes. Basically we are calling those are called as a data nodes. A name node contains majorly the metadata about data nodes. So this is a major one, and maybe you want to perform some read operation or write operation in your HDFS. So from the name node only you need to perform all these things. And like this in a data nodes, nothing but these are all the data nodes, and the data nodes will be stored in a something called as physically you are storing servers in a rack. So same way here the data will be stored. So this is a data node. This is one server, and this is another server. Here you have some data nodes are there. So HDFS major features here, if we are talking, then one of the major feature is scalability. Why? Because this is a distributed file system, so scalability is one of the major feature. Distributed storage means you can store the data in multiple nodes across the cluster. All the data nodes or worker nodes are commodity hardwares only, commodity servers. So that's why cost effective, at the same time highly scalable also. As the volume of data grows, then suddenly you have a huge requirement of additional servers. You can add those servers, you can add those nodes. So that is the advantage, that is called as scalability. Fault tolerance is nothing but if something has happened, so in that situation here HDFS provides a fault tolerance. So fault tolerance is nothing but data replication, means same copy of data is available in multiple nodes across the cluster. You have multiple racks are there, in every rack multiple data nodes are there, and there is a replication policy. According to that replication policy, data will be stored in a data nodes. So according to that minimum, here the replication factor, by default replication factor is 3. By default replication factor is 3. So means the same data will be stored in 3 files. Same data is available. If any one node is failed, then automatically another node will be activated with the same data. So that's why whenever if any node is failed, any data node is failed, so automatically you can fetch your data from the other nodes. That is the advantage. So that is called as a data replication. Automatic recovery is possible. If automatically it will detect if any node failures or any node is failure, automatically it will replicate that data block to maintain the required replication factor. If the replication factor is 3, if one node is failed, so automatically it will detect and one more node will be added to the cluster like this. And another feature, that is high throughput. High throughput is nothing but here in terms of storing the data. HDFS is optimized for high throughput, handling larger data sets efficiently. The main purpose of this Hadoop HDFS is to store large volumes of data, to handle the large volumes of data. So we are using here the larger data blocks. To achieve the large high throughput and maximizing the data transfer rate, so we need to consider the large block. Here the data will be divided into different blocks. So we need to consider the data block size something like a 64 MB, 128 MB, 256 MB like this. So we need to consider maximum size, large block size we need to consider, so that so you can minimize the overhead of maintaining the metadata operations. Metadata nothing but data about all these data nodes you need to maintain in a name node. So again it's a challenging task to your name node to handle all these metadata operations. So that's why when you are reducing the number of blocks, means when you are considering the block size as maximum, means a large, so automatically you can minimize the number of blocks, so automatically that information will be reduced. Okay, means if you are taking a smaller block size, then you will get okay, number of blocks will be increased. You need to maintain metadata about each and every block in your name node. So that is the overhead on name node. And these are the major components of your HDFS, like name node and data node. These are also called as a daemons with respect to Hadoop distributed file systems. Daemons nothing but in the background when you are working with the HDFS background, these processes are running like a name node, data node, secondary name node, three. But these two are primary, means name node and data node. Okay, so name node maintains metadata management majorly, means name node is the master node. Okay, here we are following something called as a master slave architecture. This is master and this is slave. So name node is acts as a master server that manages the file system namespace and metadata, and that is nothing but like something directory structure in your Windows, like file permissions, file creation of file, deletion of directory. Okay, something like this. And mapping data blocks to data nodes, that is also done by name node. Like you have multiple data nodes are there, in which data node so the data will be stored, that is decided by your name node. That is decided by the name node only. So single point of management, there is usually single active name node in a cluster, and it's a critical, and means from this particular node only everything will be performed, means monitoring the data nodes also done through this single node only. If something is happened to this primary name node, then you have a standby name node will be there for high availability purpose, but that is not a backup for us name node. Just to assess okay, we are using that name node. We are using, if something has happened to this name node, primary name node, then wherever that problem occurred, from that point onwards, okay, we are taking some edit log systems and image file system, and to restart that name node wherever it is stopped. So for that purpose we are using this secondary name node concept. Secondary name node, it's not backup for the name node. To assess with the checkpointing, means periodically, okay, it will merges the file system, like from 30 minutes, every 30 minutes it will merge the file system, means okay, only it will take from recent failure wherever it is occurred, from that point onwards your name node starts, not from the scratch. For that purpose we are using this secondary name node. And the data node main purpose to store the actual data will be stored, that is decided by the name node, and according to the instruction of the name node, so your data node will follows. If something is occurred to the data node, it will detect the name node, and that message, heartbeat message, will be forwarded to the name node. Name node will identify so which data node is failed, whether it is activated or not. So based on that it will take okay, replication. If that node is failed, it will follow the replication factor. According to that replication factor, so name node will data node will be replicated only with the help of heartbeat signals, nothing but continuously it will send some messages, like whether it is continuously, suppose 10 heartbeat signals are missing, means that particular data node is not alive. So means that is failed, means automatically that data node will be okay, replicated and added into the corresponding cluster. So name node and data node and secondary name node, these are the major components of your HDFS, means Hadoop distributed file systems. So that's it about basics of big data and the different formats of data, and what exactly big data, major challenges we are facing while processing the big data, and what is the difference between traditional systems and Hadoop system. And then after that we started one of the storage service from the Hadoop ecosystem side, that is a Hadoop distributed file system, and its key features and major components are demons of Hadoop distributed file system. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.